thank you everyone for joining us today. We really appreciate you taking the time to come, learn about Miovision, learn about our video detection solution, and hopefully we can really provide you an introduction to how we do video detection and what our solution looks like and how it might be able to help you or your city or the cities that you work with. So our agenda today is really a brief introduction to our detection solution. And what we're going to cover first is the platform which we actually use to deploy our detection solution that we call TrafficLink. And I'll go quickly into what TrafficLink is. Then we're going to go into the actual hardware and the web-based portal that we use to support the detection technology. Brent is going to give us a demo of what it looks like to actually configure and use detection and what cabinets and controller connections we use to integrate for that detection. And then finally, we'll get into price and features. So how much does the system cost and what can you expect to be included with the system as well? So we're going to stay super high level today. And then right at the end, I've got a sneak preview of the next webinar in this series, which goes into a little bit more of the outcomes that our customers drive using TrafficLink and detection to solve smart city problems related to traffic, either for safety or congestion mitigation use cases. Let's hop in and I'll cover what TrafficLink is. So what we've done with our technology and really the premise of Miovision and what we try to do is we like to say that we're the smartphone of the intersection. Now what does that mean? Well, imagine in your personal life, I mean, the majority of people on this webinar, I imagine next to you somewhere is a cell phone. And it used to be that you used to have all sorts of niche devices that you used in your life. You used to have maybe a calendar, a Rolodex, a phone, maybe you had a notepad that you used to take notes on. These were all independent pieces of technology or devices that you would have on your desk and that would facilitate your ability to work. Now, all those things are simply just applications on your smartphone. So if you instead of a Rolodex, you have your address book. Instead of a calendar, physical calendar, you have a calendar on your phone. So everything essentially has become just applications on top of a common set of hardware, which is your phone. And it's our goal to bring the same concept to the intersection, that when our customers have the hardware or have our system deployed at their intersections, everything that we do is simply just software on top of it. So rather than having to buy a travel time device and a detection device and a GPS time sync and an analytics platform and all these different things, you simply just have one common device at your intersection, and all those use cases and all those outcomes are simply just software built on a common platform. And we call that platform TrafficLink. And it's really our goal is to make this system the common set of hardware, really the Swiss Army knife inside your traffic cabinet that can do everything from detection to more advanced use cases, focusing on really multimodal technology. So I'll go through what the hardware components are, and I'll leave it to Brent to do a little bit more of a technical deep dive here. But we have SmartLink, which is essentially a 4G LTE modem and a cabinet integration device. That's what supplies connectivity to the traffic cabinet, as well as allows us to get at all the information inside the traffic cabinet. We have SmartSense, which we use for detection and counts as a processor. It's got 2 NVIDIA GPUs inside of it that does all the computational processing that we need at the side of the road in real time. You'll often hear these devices referred to as edge devices, and that really just means that we're bringing compute and processing right to the side of the road where we can do all these use cases in real time. And then, really important to us is our camera, the SmartView 360. That's a single fisheye 4K camera that covers the entire intersection with one camera. So for a use case like video detection, it's really convenient because you really only need one camera in the majority of use cases to cover your entire intersection and all those approaches. And then we pair that up with what we call the TrafficLink web-based portal. And of course, that's how you interact with our products, how you configure them. And Brent's going to do a little deep dive on that portal and what it looks like to actually use the detection system. But this is our common set of hardware that we install at every single intersection. And once this hardware is at the intersection, these are our applications that go on top. So if you're the smartphone intersection, you need apps, right? Every smartphone needs apps. And our apps include signal maintenance. And signal maintenance is really about the health of infrastructure, getting alerts back about events such as power loss events, detection failures, knowing, being able to get to the controller, say remotely. It's more about the remote management of infrastructure. And our customers, especially with COVID-19, are using a lot of signal maintenance in this kind of software application to make it so they can work remotely on their signals, especially from home, because it's all web-based. Our second application is video detection. That's obviously the application that we're going to cover today. Video detection is really important to a lot of cities and municipalities, and being able to supply reliable, accurate video detection in all conditions is really important to us. And certainly that application is a cornerstone of the TrafficLink platform. Some other use cases that are more operations focused maybe, or engineering focused, would be traffic insights. So this is what we call our automated traffic signal performance measure product. It essentially is an easy way to, once you install it at the intersection, just start gathering data immediately. And then we automatically turn all that data into charts and analysis and allow you to understand where congestion issues or progression issues might be occurring at your intersections. And it's, our work there is to make it so you're able to just quickly get online and look at data rather than having to mess around with, bringing that data in yourself and databases and JSON queries and everything else. Our goal there is to have you focus immediately on, the data and using that data rather than managing and creating data and data structures. So that's Traffic Insights as an application. Above that, we have some really cool new products that are pretty progressive in the market. Safety analytics is what we call the ability to provide surrogate safety measures to let traffic teams know where problems might be occurring for safety and Vision Zero initiatives. And the idea there is, how can we get away from crash data and fatality data and move to something else that indicates more, say, near misses or compliance issues at an intersection. And that way we don't have to rely on accidents and deaths, but instead we have another measure to know what's happening at the intersection. So we call that application safety analytics. And finally, we do have our continuous count solution, and this is essentially 24-hour, 365-day-a-year turning movement counts at the intersection with class. And we do pedestrians and cyclists, vehicles, and as well as other vehicle classes continuously, and even in the most difficult and largest of intersections, we're able to provide really reliable continuous count data as well. So, we have our hardware, we have our software. Brett's going to go more into detail on those, but just to give you an idea of how we think about TrafficLink and the solutions and the value it provides. And today, of course, we're going to focus in and do a bit of a deep dive on video detection. But if you have any questions about any of these other applications, we do have other webinars out there. But you can also email me or email the webinar's address that you received today, and I'd be happy to share more resources on any single one of these applications within the TrafficLink platform. Just to give you an idea of how this actually integrates into an intersection and how the architecture actually is deployed, is you would put SmartLink and SmartSense into the actual controller cabinet, and that is what would attach to the controller. Then, of course, the SmartLink itself has the antenna that goes outside the cabinet to provide cellular connectivity to the cabinet. And that's a really, really quick way of providing connectivity to the intersection. If you do already have connectivity there, let's say you have fiber or radio or something, we can just work on that as well. But if you don't have any connectivity or any comms, it's a really fast way to just add connectivity to the intersection over LTE. From there, our camera also goes up. Brett's going to show some mounting options today. This one's on just a pole there, but you can see that's what the 360 kind of degree camera looks like. And we really just mount in the optimum place to have less occlusion, so we can see as much of the intersection as possible. From that LTE connection, we do VPN into our secure cloud. We have all sorts of managed security in there to keep everything super safe. And then, of course, we do have two options. We have our portal, which again, Brett's going to go through, and you can get securely into that, and that will allow you and your staff to manage your remote deployments from anywhere, even from home. And then we also allow for secure integrations with third-party software. So you already have an ATMS, or you already use some sort of front-end interface. Our detection solutions and all of our solutions can integrate easily into those. On top of everything above that, we do have a robust data API structure. So if you do want to read data right off our system, if you want to put that into your own databases, if you, let's say you're MS2 customer or something like that, you can read all that data right into your system right from the cloud. So quite a few options for integration, and our system is quite flexible in the ways that you're able to deploy it, and I'll let Brent get into some more of those technical details. So now I'm going to hand it over to Brent, who's going to go through the hardware at a little bit more of a deep level, go through what it looks like to integrate to the cabinet, then Brent's going to take us for a little tour through the detection solution and show us what that looks like live. So Brent, I'll hand it over to you.
Thanks, Matt. That was a good breakdown. So as Matt mentioned, I'll take you a layer further into the technology, and we'll get right into the hardware and then move over to a software demo of exactly how this looks and how it works. I won't go too deep. I will explain some of the main concepts of the technologies. I won't necessarily be able to cover everything that it's capable of, but I'll definitely hit the main points here, focusing on and around the detection product. I'll start with, so Matt showed on a previous slide there that there's three main components. There's the SmartLink, that is the communications device. There's the SmartSense, which is the detection device, and then the 360 camera that gets mounted on the signal pole. So that first device, the SmartLink, it comes with the antenna as well. This is the 4G LTE modem that we often refer to as our cabinet integration device. It allows us to not only connect into the cabinet just for our inputs when we're talking about detection, but it also talks about how we can integrate for some of those performance measures, traffic analytics that Matt was showing in our solution stack there. And so generally, you see the device on the left there. It is made up of some Ethernet ports, so it's an Ethernet switch. It's got the two PoE ports that allow us to power the cameras. The 4G LTE modem, it's also 3G, 2G, so it does step down as needed. And as Matt mentioned, if you already have communications out to the intersection, you don't need to also have a 4G LTE modem out there. We just shut that off, and then you can use it in the same way, like a switch. It can integrate with many things in the cabinet, and it won't conflict with anything in the cabinet, so it's a nice, robust data machine for us. We often use this as a switch in cabinets where traditionally maybe you're already purchasing switches. This is a nice kind of 6-in-1 device, if you will. That antenna that is also there, that little gray antenna on the bottom left, that goes on top of the traffic cabinet. It's our antenna for the cell connection, but it also provides the MAC address collection for some of our travel time metrics on the traffic analytics, as well as GPS time sync. So that allows us to do cabinet time syncing and things like that. So it's a pretty robust antenna with the main function being communications as well. Just jump over to the next one. SmartSense. So SmartSense is somewhat, I often refer to this as the brains of the operation in terms of computer vision. It has our 2 graphic processor units on there, 2 GPUs, very high-powered, high horsepower device doing edge computing for us. It is simple to use, not many complexities with using this device. You plug it in, and we can configure it and get it going. You can see on the right there a quick example of the LCD screen that allows you to do some roadside validation checks and diagnostics. So it's a nice little handy screen to help us. It as well is a switch and also includes 2 more PoE ports, so that's 4 PoE ports total, and about, I guess that leaves about 4 extra Ethernet ports as well between the 2 devices. So it is it complements the SmartLink as well as a switch, and enabling us to do more PoEs. In terms of actually integrating this with the traffic cabinet, and when we're talking about video detection, the main connection that we like to use is the standard SDLC. That's your NEMA cabinets, your standard NEMA TS2 type cabinets. We connect into the same ports that other technologies would use, the same detector rack method. We're effectively a detector rack in this device. So this would be one of those detector racks. You can configure it to be all 4 of them, which allows us to do up to 64 detection channels. And as I say that, I'm sure some of you are wondering about the new ATC cabinets as well. We are working on building the additional support as well for the 128 channel version. So that is coming alongside some of our future releases so that we can fully utilize all 128 channels. In the older version of the cabinet, so looking the other way, where many infrastructure cabinets still are outdated, we do have our GPIO, our general purpose inputs to the cabinet, or field IO, depending on what type of cabinet you're using. This allows us to input or wire directly to a cabinet where standard ports like SDLC don't exist. This only allows us to do about 16 channels on those simpler cabinets, but that's generally all those controllers are doing anyway. That doesn't mean we can't do virtual detection on top of it. So we have the ability to input to the cabinet 64 channels. However, we have effectively an unlimited amount of virtual detection zones that we can create for data outcomes or different scenarios, like maybe adaptive systems want a direct input to the adaptive system. We can use the local APIs for those types of direct connections, which go beyond the 64 channels that we actually provide. So it's a very robust device, allows us to integrate with everything in the cabinet, and it gives us a nice LCD screen of what's going on there as well. The last item, the camera. This is our eyes out at the intersection. This allows the device to see what's happening in the computer vision statement. It is the vision part. It allows us to see quite a big range. Its effective field of range can get us up to 200 feet, which is really nice and robust, and that allows us to do some stop bar and then a little bit beyond the stop bar as well, so getting into the queue length a little bit, which can help us with some of those metrics. It doesn't quite get to the upstream distance, like you may be thinking about that 450, 500 foot range for dilemma zone operation. This camera doesn't reach that view. It's a 360 single point camera so that we can see the immediate intersection for operations. And you can see a couple examples of what that field of view looks like. It goes up on a signal pole, and I'll show you some of those options in a second, but it allows us to see crosswalks, the stop bars, just exactly where everybody is, and allows us to configure on quite unique intersections as well. We get both the 360 video stream, so you get the full 360 view for, say, observational type behavior. So if you just want to understand what is happening at this intersection, you do see that view. And it also gives you that detection overlay so that you can see how effectively is detection operating. So it gives you lots of visibility into its operation. So talking about mounts, it's very important to think about the mounting options and what the infrastructure actually allows us to mount to. That's why we're very robust and very customizable. We work with many detection and hardware partners across North America that allow very unique and customized camera mounting options. So not every camera mount will fit every intersection. Some of them need to be matching the scheme of the infrastructure. Some of them need to be up higher. So sometimes they have to be pretty customized. So looking at this one here, this is a mount out on a mast arm so that we can see more directly from the center view. I do like the center view a little bit better because then you get a nice equal range out to pedestrian crosswalks or out to your detection zones so that you can do more of an inequality operation. Not always is that an option, or maybe you're not even getting the height that you would like. We generally look for a height range of 28, 30 feet high if we can get it. The higher the better. Allows us to detect quite well, but infrastructure doesn't always allow us to do that, so we get creative with the mounting options, and in some cases we have to add a second camera to accommodate some of those distances and heights. There is a table available on our help center that shows height versus distance so that you can somewhat assess what you may need at your intersection, and we have a team of technical account managers that can help make those assessments of camera placements as well. So there is the option to go out onto the mast arm itself, getting you out into the intersection. The next is just right up on top of the signal upright. Those are generally the taller option, but if you're have an obscure or an odd intersection, sometimes going out into the mast arm is a little bit better. Higher is still the key, so just going out on the signal upright, we tend to get the height we're looking for. In some cases, we have more intersections like the span wire type intersections that you can see on the right there. We don't have an option to actually mount directly on the span wire, but you can easily string it out to the signal upright. Main reason, and I'm sure you're probably thinking this, the bounce of the wire can sometimes cause problems, so we tend to try to avoid it. Our device does have virtual stabilization built in, but only to a certain point, and those span wires are subject to the wind and conditions and things like that. So we'd like to go for the signal upright or the signal mast arm, and use simple tools like Google Maps and Google Earth to assess the distance and field of view that we're actually getting out of that. So lots of options with the camera mount, but definitely think through and get help if you need to get the camera placement right. And then accuracy is incredible off the device when that's done properly. So that's the hardware. Now we'll start moving over into our software platform. So the platform where you would configure it, where you'd view it, where you'd see all the operations is in our TrafficLink web-based platform. There are some local tools on the device to do things like video streaming and some configuration edits, things like that. But ultimately, the cloud has all of the robust, polished features that you can use and show off. This is what I like to show off as well. It gives us our configuration tool, video, it gives our video and detection streams. It also, if we're connected into the controller, does give us the signal, phase, and detector status as well. This allows us to build alerts around the operation so that you actually understand what might be going on out there. And so that could be your detectors maybe having problems, maybe they're on longer than you'd expect it, maybe there's cars parking. So we have some alerts built around detection operation as well as the device operation. So is the device powered up? Is it operating? Has the signal status changed in a way that maybe is impacting the detection operation, so you can start understanding the connection between the two? Why is my detector stuck on? Well, maybe because the intersection is having a different problem. And so it helps you assess some of those problems, and that's a core part of our signal management module that Matt was showing earlier. So on the detection side, we also have a layer of alerts that help us understand those operations too. And you can see we got somewhat of a view here, and I'll show you that in our demo in a few minutes. So let's get right into the detection and counts part. This is a little bit of a clip of what it looks like, and I'll show you another one shortly. This is a pretty complex intersection with a high volume of vehicles and pedestrians. So you can see almost the caliber of horsepower that this device has out there, and it's doing it all at the same time. So on the detection side, you can see we have the stop bar detection. This allows us to actually maintain operations for actuation. So this would be a detection zone that you input to the controller. There is also options to do advanced pulse zones, but not always do you have the distance to actually utilize them, but you can use them for count zones. This allows us to detect all the vehicle categories, bike and pedestrians. So you can see even in the image there, pedestrians are being detected really successfully as well. And so when it comes to actuation, we're often talking about the detection for actuation of vehicles, but this also opens up us the opportunity to do things like passive PED detection. So in our Mio Labs research group right now, we're trying to address how can we apply this to passive PED detection problems and see if we can productize that in the future, now that we have a very robust and accurate PED collection mechanism. So right now we're utilizing this for pedestrian counts, but it doesn't necessarily do the passive PED detection, but that's definitely where we're headed with this, knowing that we're approaching the accuracy that would be required for an operation like that. So it's very robust on the detection side. I talked a little bit about the counting. This gives us the 24/7, 365 count of the vehicles, the movements, turning movement. I'll show you that a little bit more, lefts, throughs, right, of all the categories. So I'm not really indicating the categories of vehicles here, but that gives you car, single unit truck, articulated trucks, and so on. So combining the detection program with the continuous count program allows you to get a very large and robust data set out of it all at the same time. I'll get into more of what you're actually seeing in the video when I get into the demo, but the first thing, before I get into that, I did want to talk about poor visibility modes in operations around video. Many customers that I work with and I talk to, they often have been using loops or radar, and I think some of the polls suggested that as well today. And they have hesitations around using video, and that could be because of all the conditions. You know, a loop in the road has very strong consistency. It's in the road. It's there, but it has its own challenges with construction management and fixes and things like that. However, it's not moving. It's in the ground. And so there's been many technologies over the years that have struggled in poor visibility mode. So I wanted to explain a little bit about how we're tackling this. And I don't disagree that it's not a complex problem. It's something that we take wholeheartedly, and we're addressing through our computer vision team and our AI machine learning approach. So what that really means is using machine learning and having visibility at an intersection like we do with our cameras, you can teach the camera to know scenarios. You can teach it to know what does glare look like, what does snow look like, what does rain look like, and you can teach in those scenarios. And the more variations of that you can see, the more it actually knows. And then when you know the gap between what it knows and what it doesn't know, you can use what we call the poor visibility fail-safe modes. And so this is where the machine learning process actually narrows down areas of like false positives or areas of fail-safe modes. So you can actually start off, say, there's a couple minutes of fail-safe operation due to visibility. Let's reduce that so it's less than a minute. But during that whole process of poor visibility, your intersection is safely operating because it's being managed by some of those mechanisms. So we have taken through our machine learning process many versions of what we have seen, and we have taught our system to be robust in these conditions, and where it's not, to become almost hypersensitive to what it thinks may be going on, and keep your intersection in a safe operation. And so this means that across North America, you get to see all of the conditions that are possible. We see up in the mountains in the snow, we see in the deserts with the sand and the wind, high rainfalls and blizzards. So you get to see all those variations, which are massive inputs to a machine learning algorithm. So Miovision, our history comes from video collection with our Scout product. We spent a lot of time understanding visibility and object recognition. And so when you combine that to an edge version, an edge computing version out in the field, we can apply all those same principles. We can use what we've learned over the last 15 years about what it takes to get accurate video or get accurate data or get accurate actuations out of it and measure consistently. So not only are we planning to do not only are we doing poor visibility modes where we're protecting the intersection, we're also able to learn from them and iterate them by measuring the accuracy that's coming off of this. And we've adopted industry accuracy measurements that allow us to understand how many missed actuations, how many false positives, and how many, and essentially how many moments were in these fail-safe operations and how to prevent them from happening in the future. So this is something that we take very seriously, and we are constantly working on through our machine learning process, and we are very comfortable describing this even more. And I believe there's even an accuracy white paper attached to this webinar as well, explaining some of our process behind it. I'm very proud of this topic and how Miovision has approached this. So we'd be happy to talk about that further. So right before I start getting into the demo, I just wanted to quickly highlight just physically what this looks like in the cabinet and what are we connecting into. And so standard NEMA TS2, we're using that SDLC port, not overly complicated. It's a single serial connection. One cable comes with the device, makes it nice and easy. When you're using a cabinet more like the 2070 version, we still utilize SDLC in many cases just over the C12 connector. That allows us to use some of those inputs in the same way, same 64 concept. Not every controller actually has that option in the 2070 world. We often get into what we call our GPIO wiring harness, where it allows us to actually integrate things with like the C11 on the 2070 side, or even directly into the back panel of the cabinet, so that you can still get the inputs and still get counts regardless of an intersection infrastructure. So this is maybe a challenge out there that I haven't had a cabinet yet that we couldn't integrate with, and I would be interested to see if we can find one. But so far, between all of our methods of connecting with our cabinets, I have yet to see one that won't work with either of these options. And so we are excited to connect to as many of them as we can either through SDLC, GPIO, field modules, anything that may work. So that's a good breakdown of kind of what the technology is, what the hardware is, and now I'm going to jump into a quick, call it 10-minute demo, and then Matt's going to finish us off with I think a couple future-looking stuff, which leaves us a few minutes for questions at the end. All right, so let me jump out of here and go over to TrafficLink. So we have a test intersection that I like to show off. We use this for a lot of our testing and whatnot. So I'll use this one to start with. So right now I jumped into TrafficLink, so I'll start maybe at the intersection version. So it is a web-based and it's a map-based platform tool as well. So when we are looking at an intersection out in the field, we can see what the phasing is. We even have a nice map overlay of the intersection. We can see what detector channels are on to help us with our mapping between phasing and detectors. And that's what we actually use for a lot of our analytics as well. How do we connect phasing to detectors to determine things like occupancy and so on. So we have a nice map overlay showing what is the signal operation happening out there, as well as all the charts that go along for the traffic analytics side. And so there's a lot of charts that come along with it. I'm not going to get into this today. It will be more so for another webinar, but it just shows you the power of how much data is actually being compiled. And so going back to the intersection, often when you're looking at an intersection, you're looking at the operation, the first thing that comes really helpful is that video. And so looking at the video, this gives us a nice live view. This is the 360 version. So looking at this, we get a nice live view of 360 video. For those that like to pan around, you can zoom in, you can look at whatever you may want to see in your observations. So there's a nice virtual pan, tilt, and zoom, or pan, rotate, and zoom, I guess is a better way to describe it. It's virtual, so the camera itself is not physically moving. You'll also notice the quality of the video. It is purposely degraded, and so it's not just your screen share that looks like this. We purposely degrade the video for privacy reasons and for storage reasons, streaming reasons. There's a lot that go along with that. And so we keep it reduced for that reason. And so if you're wondering why it looks like that, that's why. So I'll zoom back out. You can rotate around, so you can change it and look at whichever way you want. Let's reset that. We also have labels, so everything is perfectly understandable. So if you're showing others what you're looking at, you can see what those labels mean. You know what intersection you're at, what you're actually at, what approach you're looking at, so you're orientated really quickly to what is actually happening. Let's flip over to the detection overlay. So this is our 360 view, and then our detection overlay. And then we get, I'll just move it up a little bit. So now we're looking at a live detection view. This, again, we saw on one of those slides that there's the 4 boxes of detection, but in this view, we actually get the turning movement count as well. So you can actually see a live count happening, and you can assess, is it operating the way I would expect it to? So let me explain a little bit of those blue boxes. So as a car enters the frame, you're noticing that there's a blue box that goes around the object. So in the order of operations, first identify that there's a moving object, it gets a blue box. Second is it's classified. It gets a little classifier in the top left of that blue box. I'm not sure if you can see that, but V1 is a vehicle category. So instead of actually listing out what the category is in the video, we've grouped them together to simplify what you see in the video. So V1 is your light category, so it's cars and like cars, motorcycles, things like that. In the data set, they would be separated out with proper classifications. Just in the video overlay, they're combined. So V1 is your lights, V2 will be your heavies, including the buses, and then you'll see P for pedestrians and C for cyclists. So it allows you to really assess what is happening in terms of detection operation. So if I jump back to look over here, one of the best options when it comes to troubleshooting detection, which I like to use as a support person for other customers, is actually showing our customers how the device itself has local options for video storage. When you do local options for video storage, it allows you to assess how well is this detecting at night? How well is it detecting during yesterday's rainstorm? It allows you to really assess how well it's detecting. And also means you don't have to stay up all night to watch it. You can actually just do it in your office the next day. And so we store locally on the device up to about 7 days, so that you have about a 7-day window to go back and look at how did it operate. If someone called in with a complaint, you can assess the situation, because not always is the answer that there's something wrong with the detection system. It's pretty rare it's that. It's more so actually the configuration itself. So how do we adjust the configuration, or how do we understand the behavior better and apply a different configuration out to that intersection? So last thing I'll show is a quick configuration demo. Let me just go here. So in our little wizard here, there's a couple options. First is you can configure that intersection map that we were looking at earlier. You can put where's your camera, where's your detection zones. You can link all of your phases and your detector channels and so on. But then up at the top right here, we have configure our SmartSense device. When it comes to detection, visibility is super important. We want to know who has touched the detection configuration. If something's changed, or maybe construction has occurred, or you want to toggle between different models. So like say this week you have construction, next week you don't, but you don't want to reconfigure all the time. You can actually go back through historical configurations and kind of redeploy something that already existed, so that you don't have to reconfigure it every time. So I can go back. I was creating a couple of days ago, and I can just toggle through and deploy a different configuration if I wanted to, or edit my existing one and create a new one. So I can see exactly what's configured here while I highlight over it. But let's just leave the one that's there, and let's quickly create a new one. I'm not going to do the full configuration, as we probably only have 8 more minutes, but let me just quickly create a new one. And so this will show you just how simple it is and how quickly you can get one up and running. So it's divided up into 3 steps. You don't actually have to do the 3rd step if you don't necessarily care about the counts, which means there could be only 2. So the first step is more so about camera calibration. Let's give the algorithms and the system a starting point, define what is the curvature, understand what are we looking at. Eventually this is going to be automated, but for now we have to just give it a quick calibration and quick starting point. Give it a quick height, how high is the camera, and we have a little tool to help assess that if you didn't directly measure it out in the field. And so we have a quick understanding, and as I was describing before, we somewhat have this height versus distance calculation, and we are very interested in the accuracies coming off of our devices. So understanding the height that it is and some of the distances that we're doing is what we're pulling from this tool. Also telling the system what to expect out of the size of the car. How big is a car out there? And that allows us to get to an accurate detection really quickly. Directionality is very important for analytics. So which data are we looking at? Which approaches are we looking at? And then how are our phases and our detector channels associated? This also helps with quite a bit. So we utilize just basic Google features, and then we can pan around, get our directionality. So we're looking, gives you a little window there, we're looking southeast at this intersection. And now the camera is ready to go, knows exactly what it's looking at. Let's start configuring detection. So click on configuring detection. And now we get to just start going. So let's go over here. This looks like a nice, easy one. So I'll pick the first one. It tries to tell me what the approach is and names from Google. I did that step pretty quick there, so I'm just gonna change this manually to eastbound. Just say done, and now we can start configuring. I want to do a vehicle detection zone on this left turn. It automatically draws the boxes. It understands the curvature, so it significantly helps with my configuration step. And then depending on what your city best practices are for, say like loop lengths, maybe you're doing 3 cars or whatever you may be, you can continue to match your schemes. So you can do the same length that you wish. We don't necessarily, it doesn't necessarily impact us. I typically recommend go for the zone to be the length as the typical car, or if you have buses, maybe the length of a bus, but standardizing what you would like in your city is something I would suggest. So we did 1 lane here, Let's do a couple more. So we'll add that one in. I'll just do this one approach, and then we'll just quickly do the TMC. And so I'll just stretch that out. And we got a little bike lane there too. So let's add the bike lane because often these days we need to do some bike actuations. And so since we can properly identify and classify bikes, this makes it pretty handy to do a bike lane. And we also care about some crosswalks. So let's understand what the ped volumes are crossing this as well. And so we can stretch this out as a count zone. That's why it's green. It's actually a count zone. It's not a detection for actuation zone, whereas these are actuation zones. And so now we have to actually give it a kind of a designation or a channel. So if we said that this was, I'm just going to make something up, phase 1, eastbound left, just call it whatever makes sense to you. We'll say it's a left turn. This is a present zone. We want it to detect for all vehicles, not just bikes or not just cars. We want it to do both bikes and cars in case there's a bike in that lane. Give it our channel, and then hit done, and then we move on to the next one. And so you can see it's pretty simple just to line them up. Understanding your phase plans certainly helps. This would be, we said eastbound through, so you just label it accordingly, send it through. Again, we're doing all vehicles, we're doing a presence. If we wanted to do pulse, we could. We have delay and extend, so you can do the delay and extend on the Miovision devices. You can also program that in your controller. So whatever you decide makes sense to you, you can do it on either side, but it gives you the option here. Many product approval labs require the technology itself to do those applications, so we have it built in nicely. And then on our bike zone, we'll call this a through, say a through right bike. We'll say it's also phase 2, but part of the bike phase. We'll say that this is present as well, but we'll say just bikes. Just tell me when this is bikes. And then I'll just make that channel for now. And so this allows you to move it in. Often I get the questions about, can I put it into the intersection? And the answer is absolutely. You configure whatever makes sense for your intersection and for the operation that you're looking for. And you can always adjust afterwards. So it being a remotely connected device, you can simply adjust it as you need. And so that's it for one zone. We have all the zones drawn. We have them labeled. We have them associated with channels. And then we'd work our way around the intersection as needed. I won't spend too much time on the turning movement count configuration, but it's just as easy. It just says, where are you looking to count cars? I want to count cars in this area. It automatically labels it for us, which is nice. I'll hit next. You size this out for movements just to get your ins and outs right. And then you work your way through the lane checks to understand which movements am I actually looking for each leg of the intersection. So again, I guess the theme here is robust. You can configure for multi-lanes, you can configure for single lanes, lefts, U-turns, whatever you need out of the system, you can simply configure it to do so. And so I'd say this looks good, I'll hit done. And then if everything looked good and I was happy with my configuration, I could save it for later, for someone else to approve or to look at, or actually just hit the deploy button and deploy it out to the intersection and begin operations. And when you deploy it, it takes about, well, the speed it gets from through the device to the cabinet, it takes only about a matter of seconds, and then you go live at the intersection immediately. And so it's nice and quick and easy to set up, and then away we go with the detection operations. And so here you're actually seeing, I'll just, in my last minute I have here, you can see some of the detection zones go green when there's occupancy. We do have some count zones in place here for just general pulse type counts. So if you're doing some advanced operations, you can. We have the pedestrian crosswalk counts as well as the vehicle turning movement counts all at the same time. So it gives you a nice canvas to design your intersection operation as well as get clever data out of it all at the same time. So thank you for watching the demo. If you want to see more or you want to go further into some of these applications, I'd be happy to do one-on-one sessions or do a repeat of this. But for now, I'll hand it over to Matt to maybe wrap us up.
Thanks, Brent. I'm just gonna take over the screen share. Perfect. So thanks again, Brent. We really appreciate your time and taking us into some detail there. Hopefully everyone found that pretty useful to see exactly how the system operates. I got a few more details to share with you, including the pricing of the system. So finally, just going through the MSRP of the system. So it's 14.9 USD, and that includes all of your hardware and includes the software as well, and it has no reoccurring cost. So we do have modules that you can add to the system that do have a cost, but if you are using us for just video detection and video detection only, there is no reoccurring cost on our system. So what's included feature-wise? Of course, you get stop bar and pulse actuation. You get remote detection configuration, so you get remote access from anywhere in the world. So whether it be from your office or your TMC or even from your home, to be able to remotely configure the system and video stream to be able to see exactly how your configuration is doing at about 2 hours a month of video streaming. We also have real-time streaming protocols, so RTSP feeds right off the device. So if you do have VMS systems and you're looking to pull that video in, you can do that if you have your own connectivity at the intersection. If you don't have your own connectivity at the intersection, we do offer our signal communications add-on that can provide that connectivity and that cellular device connection to provide that as a cloud API as well. Same thing for any real-time APIs. So if you're looking to capture data or looking to do something like an adaptive integration, we have all those available on the device and you get that included as well. We also provide over-the-air updates, and those are automatically deployed to the devices for security and algorithm performance improvements. If you do want control over when those updates are pushed, we have that option as well. But all those updates for your device are included. We have both roadside and local configuration. So if you are looking to configure locally at the intersection, it's something that our software team is currently working on right now. And then we also have the device-based access to the TMC data that Brent was talking about as well. And if you do have your own connectivity, we can leverage that to pull that data back in addition to having it at the cabinet. And again, if you at any point want to add connectivity or have connectivity at your intersection for those other use cases, we obviously offer that as an addition to the system. So just again, just to wrap up, what we did talk about today was obviously our video detection solution. We do have all these other solutions that run on the same platform. So if you're going to invest in a video detection solution, we would encourage you to invest in a solution that has multi-purpose, a little bit of a Swiss Army knife that solves multiple problems within your traffic cabinet, not just video detection. So if you're interested in video detection, but you also think there might be value in the signal maintenance and the connectivity, in data or safety or getting those counts, we feel strongly that it's much better to have a very robust platform like TrafficLink at your intersection than a single purpose or a single use device. So if you're interested in anything that TrafficLink can do in addition to video detection, again, please email us and we'd love to have a conversation or give you a demo of what some of these other software modules look like for TrafficLink. Before we get to questions, I'll just let you know this is actually the first part of a series of webinars. So in this webinar, we really covered the basics. This was meant to be an introduction to our system and how it works. Our next one is going to be more focused on the outcomes and how we can use video detection in our software to really solve mobility and congestion problems. And we have some really excellent use cases from our customers who are all over North America about how they've gone from roadways that have been a very, very large challenge for them to deploying TrafficLink and seeing traffic problems kind of evaporate overnight. So that's going to be September 23rd at 1 p.m. Eastern. I'll be back to host that one as well. And we're really going to go over all those outcomes that not just citizens are looking for, but councils and mayor's offices, and how do we share and really promote those amazing results that traffic technology like TrafficLink can have on your city. So feel free to register for that one. Send it to your colleagues, send it to someone you know that might be interested. Again, there's no cost at all for our webinar series, so please feel free to spread it far and wide. And with that, I'm going to get to some questions. So so we just dropped the link in the chat there too. So if you want, you can sign up with that link directly. So I'm going to hop into the questions, and I apologize. We've got, what do we have? We have about 4 minutes left, so I'm not going to get to everyone, but I'll try to group them into buckets, and that way we can address them. I have some questions here about 5G. So, right now our system does have the ability to include that 4G, LTE, 2G connection. We are looking at 5G. Right now, there is no real 5G spec out there in terms of antennas. So our hardware team and our product teams are currently looking at that solution. And as soon as there's a spec or an industry standard for something like that, we plan on, of course, adding it to our system. But 5G is one of those things where no one's quite sure what the specs are, what it's quite going to look like yet. So we're definitely on 5G, and we plan to be part of that. So questions about the connection capabilities. Is it IPsec? Is it VPN? Yeah, we do have a proxy. We call it Mioproxy that connects to our cabinet that customers can use to access those devices, and it is of course secure over the LTE connection as well. So yeah, we take our tunneling and our VPNs quite seriously, and if you're interested in that, we have some resources that can help you out. We can share. Here's a question for you, Brett. What is the weight of the camera and the mounting system that would actually go up on the arm? Like how much does it weigh all in the camera?
That's a good question. Off the top of my head, you're looking at about, I would say, with the mount itself, so if you have an extension mount plus the camera on top of that, you're looking at about, call it 10 pounds, 10, 15 pounds. It's pretty light overall.
Awesome. Now I have a group of questions here, and so I'm going to group a few of your questions into one mega question, which is, Brent, can you walk us through a little bit about how you think about camera height and accuracy and something like lens maintenance and how often you have to go back to the system?
Sure. So on the maintenance side of that question, it's a common one that we hear because cameras out there in the elements tend to get dirty over time. However, I have seen such a large range to that answer. So in areas where there's high truck volume, I tend to see a little bit more of the emissions coming at the camera from the top of the truck stacks, and they tend to need cleaned every 6 months or so. And then we have corridors that are more pedestrian focused and bike focused, and there's a lot less truck volumes where they can go years before they need to be cleaned. And so some of where poor visibility modes come in and just general observation things, you'll be able to see in the video, and then eventually get to a moment where it actually goes into a failsafe because the visibility due to whatever has gotten so far. So the answer is pretty long or pretty ranging, but generally it helps just to observe it every 6 months or so to just make that assessment. In terms of the actual camera design, the bell of the camera actually protects the lens of the camera really well from the elements. So it's actually pretty hard for dirt and whatnot to get on the lens because it usually drips around the lip of the camera, not actually the lens of the camera. Sometimes it does. Sometimes rain comes from all directions, but it's pretty rare. So the way we design the hardware is to actually prevent exposure of the actual lens itself.
Perfect. I'll do like a quick fire question and answer here. How does the camera get powered? It is powered over PoE, so it's a single cable, just RJ45 that goes up to the camera, and that provides the data connection to the camera as well as the power. Are your data APIs third-party, open, or proprietary? Everything Miovision does is open. We believe strongly in open standards and open protocols. And you can actually, if you go to api.miovision.com, you can actually read our APIs and what's included in them. Is the system currently deployed? Yep, Brett was showing a system that is currently deployed. That system was in the region of Waterloo in Ontario, Canada. But we have live systems all over North America. I believe we're up to 1,700 different municipalities and cities that we service. So the system is in the field operating and all across North America. Trying to see if yes, if you do have a large intersection, we do support multi-camera deployments. So if you have a really big intersection, we are able to put 2 cameras over that. And any international standards, so we are NEMA compliant, and then we also work with bodies like the Turo Lab out of Florida to validate accuracy and those kind of recognition of standards and spec and meeting that spec as well. And we also apply to all APLs within state agencies as well. And then finally, the one that I'll get to here is, can you make this handout presentation available? For sure, and we will also follow up with a recording of this webinar as well, so you can read it. So I guess I'm going to leave it there. I see there's some questions that I couldn't get to, but we're a minute over time, so I'm going to wrap up. But what I'm going to promise is that someone from Miovision will reach out to each single one of you and have your questions answered. And again, if you have any questions and you want to talk to either Brent or I, feel free to email us. We would be happy to continue this conversation. But we are at a time, so I'm going to wrap it up there. Thank you for your time today. We really appreciate it. Thank you especially to everyone who stuck around for our kind of bonus time here and having questions answered. And we really look forward to answering your questions and getting back into contact with each and single one of you. And hopefully we see you at our next webinar on September 23rd. Thank you, Brent, again for your time today. We really appreciate it. And for everyone out there, we'll see you at our next webinar. Cheers.